Okay, I would like to ask from Janice. Janice, hello Janice, are you there?
Yes.
Yeah, Janice. I would like to ask what is the meaning by first ionization energy? It is written
Um,
in the textbook. Yes. First
uh,
ionization energy. Yes, Janice.
I don't know, teacher.
Oh, okay. First ionization energy. Then I would like to ask to Nia. Hello, Nia.
Yes.
Yes. Can you find on the textbook what is the meaning by first ionization energy?
First ionization.
First ionization energy is
It is the required to move 1 mole of the loosely held electrons from 1 mole of gaseous atoms to produce 1 mole of gaseous ions, each with a charge of 1 positive. This
yes, correct, Nia. Exactly correct, Nia. So
uh,
energy required to move 1 mole of electron from 1 mole of gaseous atoms in order to form 1 mole of gaseous ions and an electron. And then here, so first an energy required to remove 1 mole of electron from 1 mole of gaseous atom to form 1 mole of gaseous ion. And then state and explain the trend. So here state and explain the trend in the first ionization energy as group 1 descended. Okay, we have to write as uh, go go down the group elements have oh wait, atoms have more electrons. That makes more electron shells. More electron shells shells make mm, higher or make greater uh, shielding shielding from inner shell inner shells and lower nuclear charge lower nuclear charge. Therefore the ionization energy of atoms go down the group decreases decreases. Okay, and then to suggest how this trend helps to explain the increase in the reactivity of the elements as the group is descended. Okay, as the elements descended descended this descended outermost descended the outermost, so here, okay, so as descended, let me write again, as elements descended uh, descended down the uh, outermost electron easy to lose. Electrons responsible for the chemical reactivity. Okay, so the electron responsible for the chemical reactivity. That makes if the electrons easy to lose, so the more reactive the element is. Okay, next, in a redox reaction, 0.83 lithium reacts with water to form 0.5 liter of aqueous lithium hydroxide. In here, we have to find A, the first question, calculate the amount of moles of lithium that reacted. So we have to find the amount of the lithium reacted from the number of moles. So moles of lithium equals to mass divided by molar mass, and moles of lithium equals to 0.83 divided by 6.9. Why 6.9? Because the relative atomic mass of lithium is 6.9, and then it is become 0.1199, and then which is round off becomes 0.12 moles. Okay, 0.12 moles. And then next, the second page. Calculate the volume of hydrogen produced at room temperature and pressure. Calculate the amount of hydrogen produced at room temperature and pressure. We know that the hydrogen and lithium is 1 to 2. It means one hydrogen. So based on moles, so here we write, so we have to write over here based on moles. So based on the ratio of molecules of the reaction, comma, to lithium equals to 1 hydrogen gas. 1 hydrogen gas. So it means if the moles of lithium equals to 0.12, therefore moles of hydrogen gas equals to 0.12 divided by 2, which is become 0.12 divided by this one, 2 equals to 0.06 moles. And then volume equals to moles times 24. 24 is the molar volume of gas. And then we find here volume of hydrogen gas equals to 0.06 multiplied by 24, which is become 1.44 decimeter cube. And then calculate the concentration in mole per decimeter cube of the lithium hydroxide formed. So calculate the concentration. So here we have the mole of now ratio of Li and lithium hydroxide equals to 2 2. It means moles of lithium equals to moles of lithium hydroxide. So moles of lithium hydroxide equals to 0.12 moles. And then the concentration, the concentration of the lithium hydroxide, so here concentration of lithium hydroxide equals to 0 of moles divided by volume. And then we know the volume was 0.5. So concentration of lithium hydroxide equals to 0.12 divided by 0.5, which is become 0.24 mole per decimeter cube. Mole per decimeter to the power of 3. Okay. And then this one about chlorine. This one about chlorine. When heated in chlorine, all the alkali metals react to form corresponding chloride. Describe what you see when sodium is heated in chlorine and write a balanced equation for the reaction. So how do we explain this one? The changes. We have to write the changes. Sodium metal is very reactive. It will explode. It will have an exothermic reaction when it is exposed to air. Okay, when exposed to air. Exposed to air. And then chlorine gas is greenish yellow at RTP. When both reactants react, becomes sodium chloride that has white in color and in solid form. On bracket, white solid, different property. So the equation here will become, so the equation here will become 2Na, which is solid, and then plus Cl2, which is gas, will become 2Na, become 2NaCl, which is solid form. So this is the chemical equation, and then the description of how the reaction occurs, and also the property of the constituent elements. Okay, and then now let's move to next page. The first 6 ionization energy of an element X are given below. Define the first term, the term first ionization energy. Okay, Nia had told us the meaning of the first ionization energy. Now, I would like to ask to Atta. Hello, Atta. Are you there, Atta? Are you in front of your mobile phones, Atta? Hello, Atta. Atta? Okay, maybe Atta is doing something. Okay, then let me ask to Mario. Hello, Mario. Mario? Oh, Mario is also busy. Okay. Then let me ask to Max. Hello, Max. Hello, Max. Are you there, Max? Oh, Max is sent out. Oh, hello, Max.
Yes, hello.
Hello, Max.
Yes, yes.
It's good to hear your voice again. Can you
Okay.
open your textbook, chapter
Next.
2? Yeah, textbook,
Yes.
chapter 2.
Chapter 2.
Yeah, find the definition of first ionization energy.
First ionizing energy. Okay, with teacher.
First ionization energy. After this, Mario, I would like to ask you for question B. Write an equation which states symbol for the second ionization energy of element X. Okay, we are waiting for Max. Okay, we are waiting for Max. Uh, I will ask you a question. Um, B. Okay, Mario. Okay, so we are waiting for Max. Max, what is the term first ionization and energy? Okay, okay, Max, have you found it?
Not yet, not fine.
Huh? How come not fine? You have your textbook. It is written. Who's that? Nia could answer very well.
Oh, yes, wait, wait.
Nia could find. Of course, you can find Max because you both of you are using the same textbook.
Oh, this one.
Yes. What is it? Can you?
First ionization energy is the energy required to remove 1 mole of loosely held electron from 1 mole of gaseous atom to produce 1 mole of gaseous ion with a charge of 1, positive 1.
Yeah, correct. Yes, correct. Finally, you found it, Max.
Yes.
Okay, now B, Mario. An equation, Mario, for the second ionization energy of element X. Hello, Mario. Mario, can you tell us what is the equation? What is the equation for the... Oh, it is written on your textbook, Mario. Written on the textbook. Yeah, we are waiting for you to check. Okay, we're waiting for Mario. Okay, Mario. So the second ionization energy is X plus gas become X 2 plus uh, plus electron. Yes, X plus become X2 plus electron. And then, okay, and then next, use the data given above. Use data given above deduce in which group of the predictable element X is placed. Okay, I need help from Atta. Hello Atta, are you there, Atta? Oh, Atta is still busy. Is Atta, are you in front of your mobile phone? Okay, Atta seems busy. Okay, let me try with Brian. Hello, Brian. Brian, are you there, Brian? Okay, Brian seems busy also. Okay, so this one we have to find the log number of each one. This one we have to find log the log number of the logarithmic, the log base 10. So the value of 950, so this one, the log of this one, the log of 950, if we use calculator, then so 950. Okay, so it is log 950 equals to 2. This one we have to find of each log, and then this one also it has its own logarithmic value, and then here logarithmic value, and then also this one, and then we find here logarithmic value is 2.98, and then for this one, for 1800, so log 1800 become 3.26, and then 2700 we have to find the log, also log 2700 3.43, and then log 4800 3.68, and then for 6000 it is log 6000 equals to 3.78, and then for 12,300 log 12,300 becomes 4.09, and then from here we have to find the difference between this one. Okay, the difference between this, the difference between this one, because between 2000 between 2.98, where is the pen? Let's find the pen. Okay, 2.98, the difference, we have to find the difference of each log. If the highest difference, it is the jump of the outermost shell. So from here we can see the outermost shell is 5 electron. So it's group 5. Explanation: there is a huge jump in logarithmic base 10 calculation from 5th to 6th, meaning the 6th electron is located in the inner shell. Okay, so when it moves, it creates a huge jump. Okay, now let us see the next question. Okay, next question. This one. First ionization energy of group 4 given below. Explain the trend shown by these values in terms of atomic structure of the elements. Structure of the elements. Okay, this one. These elements are in group 4. They are down the group. We know down the group elements have more electrons. Then they have more electron shells, higher or greater shielding from the inner shell and lower nuclear charge. If they have lower nuclear charge, means the effect they have lower first ionization energy. Okay, so these are the trend. Okay, next, this one. In the 19th and 20th century, scientists established the atomic theory and showed that the 3 subatomic particles, proton, neutron, and electron, the masses and charges of these 3 particles were subsequently determined. When separate beams of electrons, neutrons, and protons are passed through an electric field in the apparatus below, they behave differently. And then which of the 3 particles will deflected most? Which 3 particles will be deflected most? It is the electron. Electrons. In which direction? Towards the positive end. Why is it deflected most? Electron will be deflected the most because electron is the lightest. Its mass is 1/1840. So it's very small. So it's considered to be negligible. Very small. And then this one, define the term proton number. Proton number is, so here proton number equals to atomic number. Okay, proton number is atomic number. Why is proton of an atom of element usually different from nucleon of an atom of the element? Nucleon is proton plus neutrons. Protons plus neutrons. The protons of the proton number of an element is different from the nucleon number because nucleon contains neutron that does not have any charge, doesn't have any electrical charge. Okay, different from proton. Okay, and then the last page, proton and neutrons have been used in nuclear reactions which result in the formation of artificial elements. In such process, proton and neutrons are accelerated at high speed and then fired like bullets at the nucleus of an atom of an element. Suggests why neutrons are more effective than protons as nuclear bullets. It is because neutrons do not have any electrical charge, so they will not be deflected like protons. Okay, and then what effect does the presence of an extra neutron have on chemical properties of the new atoms formed? Presence of an extra neutrons will not give any effect on the chemical properties because neutrons do not carry any electrical charge. Okay, only electrons responsible for the chemical properties of an element. Okay, so only electrons responsible for the electrical property. Okay, so this is the review for today, and on Friday we are going to have the revision test of chapter 2 for chapter atomic structure of the atoms. Okay. Before the class end, I want to take attendance and take attendance 11p. So there is no Alicia, there is no Alberto. Carlton was here, but Carlton has signed out, so Carlton is not here. Atta, Carlton not here, and then Atta is here. Billy is not here. Then Billy is not here, and then Eiffel. I do not see Eiffel, and then Hayato. Hayato is here.
Yes, I'm here, sir.
Janice here, Kyla here, Kevin P here, Kevin N is not here, and then there is Mario, Matthew D, Max. So Mario, Matthew D, Max, they are here, and then Natania here. Oh, there is no Risky. So there is no Risky, and then there is no Saka, Sarah. There is no Shannon and Valentino. Okay. Okay. So all these are here. Rest of them are not here. Okay. So you have to study and please submit the worksheet to this worksheet to turn in, or you can send by email. I think you know my email, and then I'm waiting for your work today. Then we will discuss tomorrow, Wednesday and Thursday, and then Friday you are going to have test. Okay. Good afternoon, students. You may leave the discussion room.
Thank you, teacher.
Yes.